This next chapter, we're going to be talking about similarities and similar figures, triangles, and different polygons. So first we need to talk about the basis of it, and that is about ratios. So a ratio can be written different ways, and a ratio of A to B can be written as A over B, so as a fraction, or you can sometimes see it as a side-by-side ratio, so A and then a colon B. And as long as the B is not equal to 0, this will work. So we always need to write them in simplified form. So we always need to make sure that we reduce our fractions. Equivalent ratios are when we have, two ratios that have the same simplified form. So in this rectangle, if we need to write the ratio of the width to the length, we have to make sure that the width is over the length in our ratio. So we're going to have 6 inches over our 10 inches. And then when we reduce it, the inches are going to cancel each other out. We can divide both of the numbers by 2. So we end up with a 3 over 5 as our ratio. For the next question, if we have 240 students eating lunch, 96 purchase their lunch, and the rest of them bought a bag lunch, what is the ratio of students purchasing to the students that are bringing? So first off, we can set up a ratio like we've got right here. So purchasing, and then our colon, and then bringing. So we need to find the number of purchasing, number of bringing. So we've got the purchase, and that's the 96. That part's the easy part. But then for the number that's bringing, we have to do some different calculations. So we know that there's a total of 240. And if we subtract out the 96 that are purchasing their lunch, then we end up with 144 that have the lunch that they are going to bring. So if we reduce it, and this is where you want to think of your, let's see, scribble that out. So remember on your calculator, you always want to do your math, and then enter is going to be your best friend on all these different reducing problems, so just remember that. So if we reduce it, we end up with a 2 and then a 3, so our answer is A. In a question like this one, first we need to draw a triangle, so CDE. It does give us a ratio of 1, 2, and 3, but we don't know what it's being multiplied each time, so what we're going to do is we're going to put an X with each of those numbers inside. We know that all numbers, or all of our angles, add up to be 180 inside our triangle, so we can add all those up to equal 180. So this gives us 6x equals 180. So then x is equal to, if we divide that, we get 30. So we need to put those 30 back in for all of the x's, and that means that we will have 30 degrees, 60 degrees, and 90 degrees for all 3 of the angles inside our triangle. Next up, we have proportions, and a proportion is an equation that states the two ratios are equal. So one of the biggest ways of simplifying this is by cross-multiplying. So I would multiply my red times my blue. So the cross product property is in a proportion. The product of the diagonal down, so that's really my red numbers up there, so the extremes. And then the diagonals up is in my blue, and those are called the means. And if we cross multiply those, that would mean we're going to be taking A times D, and that's going to equal B times C. So the biggest part that I put on here is that when you're cross multiplying, the whole idea is to get rid of the ratio, so make sure that there's no more ratios remaining after you multiply. So in this first one, when we actually do that, we're going to take our 5 times 16 and set it equal to our 10x. So once we multiply that, we get 80 equals 10x. We have to divide by 10 on both sides. So we get x equals 8 for the first one. For the second one, we have to take our 1 times the 3y, and then our 2 times the y plus 1. Make sure you make a little note here. You have to distribute, and that's because you have something that's being added on one of your parts of your ratio. So we will get a 3y equals my 2y plus 2. Subtract my 2y over, so I end up with y equals 2 for that answer. Now this is where we are going to start using our ratios to start setting up our own proportions. So what you want to look for is we see AB is right here is 15, and that's going to be paired up with our 5. Next we have BC, and that is right here, and that's going to be paired up with my 9. So when we're setting up a proportion, then I need to match up my corresponding pieces. So the AB is my 5, and that is my 15 in my triangle. And then for the 9, that corresponds to the 5r plus 2, and now we can cross multiply to solve this. So we need to distribute our 5, and then also multiply 9 times 15 together. So on the right we get 135, on the left we get 25r plus 10, and when we subtract our 10 over, I'll have 25r equal to 125. Once I divide by 25, my r ends up being just a plain 5 in that first one. All right, so in this next problem, it tells us exactly how to set this up. So my mn needs to go first, so that's my 8. Next is rs, and that is my 10. Next, I need to do my np and then st. So np is my 4 over st is my x, and then I can cross multiply. So we're going to do our 8 times x equals our 4 times 10. So we get 40 equals 8x. When I divide by 8, I also end up with an x equals 5. Not really intended. This next question looks like it's a little more difficult just based on the picture, but again, remember, notice if they give you what the proportion is supposed to be set up as. So BD is first, and that's the part we do not know, so I'm going to leave it as BD. Next, we know the DA is my 3, and then BE is 18. And EC is my 6. So notice the numbers I'm using right here. Then if I cross multiply this, I'm going to leave it as my 6 times BD, but I can simplify the right hand side as 54. So then when I divide by 6 on both sides, I end up with BD, sorry about that, equals my 9. Okay, so if BD itself right there is 9, but I want the x, I need to add those two pieces together. So my 9 and my 3 need to be added together. So my x in my picture is going to end up with 12, and that is BA. So BA is 12, and BD is 9 in that problem. Mr. Jones has taken a survey of college students and found that 90 out of 106 students are liberal arts majors. All right, so that's our first ratio we're going to be using. So we know that they did liberal arts students versus all the students. And that is our 90 out of 106. Okay, so then the college has this number of students, and since students is on the bottom of this fraction, we're going to put our 7,596 there. And then when he wants to know how many students are liberal arts majors, that goes on top. So when we cross multiply, we're multiplying these pieces together. When we multiply them, this is what we get. Then we have to divide by 106. So we get 6,449.433 around, and that would be our letter D. Where this will come in handy is when we are going to be using scale drawings to predict what the dimensions are of an object in the drawing or in real life. So a scale drawing is a drawing that is the same shape as the object it represents, and the scale is going to be using a ratio that describes how the dimensions in the drawing are related to the actual dimensions of the object. So in this first one, for the scale model of this train, is 1 inch to 5.4 feet. That means that this is what this ratio is going to look like. And one thing that I always do is I label, if it's in inches, that's obviously the model, so the other in feet is the actual length. So that way when I'm given this 10 inches long and that's the model, I know that goes on top with the same area in my ratio. So I'm going to have my 10 inches on top, and then if I want to know how long the actual train is, that's my x on the bottom. So it's a little bit easier to fill in the pieces, and then we can cross multiply. So when we multiply this, we just get x equals, and that would be 54. So remember, we are finding the actual. This would be in feet, and don't forget the units. All right, so we're using the same ratio and scale factor to set this up. So for this problem, we are given a 13.5 feet, and this is the actual height of the train, so actual goes in the bottom. So 13.5 feet. And then we want to know how tall the model is. So when we cross multiply, we end up multiplying the 5.4 times x and the 1 times 13.5. So this really doesn't change much when we multiply it out, but then we have to divide both of them by 5.4. So we get x equals 2.5. Remember, we're finding the model, so this will be in inches for our final answer. All right, so for these last two questions is now we can use this scale for a map for distance, because it's a really common way that this ends up. So I would write this really as a 0.5 and not really as 1/2 inch. So if you notice, I wrote on here also that this 0.5 inches is for the map. The actual is my 14 miles. So next we need to fill in our piece of information they gave us, the 448 miles. So let's match up our units. So that goes on the bottom. How far apart are they on the map? That's going to be our map distance, so that's on top. So now when we cross multiply, don't forget the 0.5 in there. And half of 448 is 224. And then divide that by our 14, and we get 16. Since this is the distance on the map, this will be in inches. So our answer that matches that is our letter B right there. So next one, they give us a little mini scenario. So it's 6 hours to produce 25 parts, and there's the ratio. If you get really good about labeling all of your ratios, it becomes much, much easier to fill in the missing pieces. So if they give us this 24 hours, we match up the hours with the hours, so that number goes on top. And then we need to find the number of parts for the bottom. So if we cross multiply, we end up with 6x equals 600. Divide by our 6, and we end up with 100, and it is the units at the bottom, so it's 100 parts. So that would be our letter C answer right there.